Hello and welcome to my channel ZeroToSiva. Today is day one of this playlist. So let us get started with our actual agenda. I'll show you the agenda for now. Let me share my screen. Yeah. So today we'll understand in detail about how modules work in Mule. We'll understand about modules in detail, and we will see how class loading isolation issue is resolved in Mule runtimes. And most importantly, in interviews, they'll ask this question: how to share common flows across application. So you'll learn all this in this video. And to tell you frankly, this topic requires you to know basic Java. If you are totally new to Java, you may not understand whatever I am telling. You need to know basics of Java to understand this topic. Anyways, if you are planning to grow as an architect, you might be knowing Java is mandatory, right? Fine. So assuming that you have some basics of Java, I'll continue. So let us start about one problem. I hope you know that Mule runtime is a Java application, right? We know that whenever we start Mule runtime by executing mule.bat, if you've seen my developer videos, you understand that whenever I execute mule.bat, it will internally start a Java service wrapper called as Tanuki. Hey, if you have not seen my developer course videos, go and see there is one video about Mule runtime, how to start, how to deploy applications on Mule runtime. I have clearly discussed in that video how Mule runtime starts, and whenever you execute mule.bat, what is this Tanuki's role, everything. But now, hoping that you have seen that, let me continue. Whenever I execute mule.bat, internally mule.bat will start a Java service wrapper called as Tanuki, and this will start. This will actually load the configuration from wrapper.conf, and finally this Tanuki will start a Java application. How do we start a Java application? Java space class name, and we can pass environment variables using -d option. -d key 1 is equals to value 1, -d key 2 is equals to value 2, etc. before class name. And we can also pass -x options, -xx options, the JVM arguments also before class name. So internally, this Tanuki will start a Java application. And I wanted you to clearly keep in mind that Mule runtime is nothing but a Java application which will be running within a JVM. So as Mule runtime is a Java application and our Mule applications are also Java applications, let us try to understand some problems we commonly face in Java applications. First one is a class loading isolation issue. What is this class loading issue? Let us see. Assume that I'm developing an application called as My App. Assume that I'm using Maven for building my application, and my app is dependent on a third-party jar called as a.jar, and assume that it is dependent on a-1.1 jar. Okay. And my application is also dependent on some x.jar, and it is possible that this x.jar also might be dependent on a. So, and assume that it is dependent on a-2.1.jar. So my app is dependent on a-1.jar and x.jar is dependent on a-2.1. Different versions of same jar. Okay. So if you are using Maven, actually what happens, whichever jar comes first in class path, that will be used. Actually, my application specific dependencies will be given precedence over the transient dependencies like this. So whenever I run my application, actually the classes belonging to a-1.1.jar will be executed. But when we are actually utilizing the logic in x.jar, and if x.jar tries to load the classes, they will not be loaded from this 2.1 jar, they will be loaded from 1.1 jar, and at runtime we will face issues. This is a problem in any typical Java application. But in Mule, how they are addressing this problem, right? So let us talk about it. So again, let's assume that I am developing a Mule application, my app, and assume that it is dependent on DB module and also, for example, SOAP module. Okay. And it is possible that the database module is dependent on some third-party library like Apache Commons 2-2.1 jar. And this SOAP also might be dependent on Apache Commons, but 3.1 jar. So there is a conflict. SOAP module requires 2.1 and DB module requires, sorry, SOAP module requires 3.1 and DB module requires 2.1. How do we resolve this conflict? Actually, in Mule, what Mule does is, for every module, it will use a separate class loader. Actually, if you know basics of Java, you know that class loader is the one which will load the classes into JVM, right? So actually, for every module, Mule uses a separate class loader. So for database module, there is separate class loader. For SOAP module, there is separate class loader. Actually, in Mule, every module is treated as an artifact. And even my app also is an artifact for Mule runtime. So for every artifact, there will be a separate artifact class loader. Okay, confusing, right? Yes, don't worry. I will explain you. So before I explain you in detail, let me just again give you here. Concept you need to understand is classes loaded by a class loader 1 will not be visible to classes loaded by another class loader. That is the concept. So classes loaded by the class loader belonging to DB module, the classes loaded by class loader of DB module will not be visible to the classes loaded by this class loader. Okay, confusing, I know. So let me explain you in detail. This is Mule runtime. This is Mule runtime. Mule runtime is a Java application. Actually, for every Java application, there will be a default class loader called as system class loader. And in Mule, they have written their own system class loader. Let me show you actually. I'll open Mule Anypoint Studio, Control-Shift-T will show all the classes. I'll write star class loader star sys. Do you see there's a class called as Mule container system class loader? Yes, this is from org.mule package. So internally, when Mule runtime is getting started, that system class loader will be specified as a class loader. Okay, fine. Now, inside this Mule runtime, assume that I'm deploying my app. This is my app. My application also is treated as an artifact. So this will be loaded by its own class loader called as artifact class loader. So for every artifact in Mule, they have written a separate class loader. Let me show you again. I'll just write RT. See, is there something called as artifact class loader? Yes. So for every artifact, a separate artifact class loader will be used. So for my app also, a separate artifact class loader will be used. And assume that inside my app, there is DB module and SOAP module. For each module, a separate artifact class loader will be used. Now, let me give you clarity. There is a parent and child relationship between these class loaders. I'll give you clarity. So actually, system class loader at the runtime will be the parent class loader. So whenever Mule runtime starts, all the classes which are used by Mule runtime will be loaded by this system class loader. Then whenever your application is getting deployed, for your application, a separate class loader will be created by this system class loader. So this is app class loader. App class loader will be a child to system class loader. Okay. Under this app, there are two modules, right? DB module and SOAP module. So for each module, again, a separate class loader instance will be created. And this DB specific class loader will be a child to app class loader. SOAP class loader also will be a child to application class loader. This is the hierarchy. Now the concept is classes loaded by the child class loader will not be visible by default to other class loaders, right? That is a default behavior. In Mule, what they have done is each class loader, if this class loader has loaded some classes, they have defined something called as public API. Every module can define its public API. Among all the classes loaded by this child class loader, what all can be visible to other class loaders can be defined inside the public API, and those will be visible outside, others will not be visible. So again, still confusing, right? Let me show you here. Actually, this is a confusing topic. If you are totally new to Java, you might need to watch this video multiple times again. Don't worry, but complex topics needs to be understood. Okay, fine. Let me tell you. Here, this is a sample Java application which I have taken. Here I have this module HTTP. If I expand, in every module, there are multiple jars, is it? There's a jar ending with -mule -plugin. Actually, this is the main jar. A jar ending with -mule -plugin is a main jar. But this jar is dependent on other jars as well. These are all the other dependent jars. Fine. Now, in this main jar, if I expand, there are a lot of packages and classes. Under that meta-inf, Mule artifact. Here is Mule artifact.json inside this. If I open this, here you can see there is something called as exported packages, which is an array of all the package names. So only the classes belonging to these packages will be visible to the other class loaders. So I can say that for HTTP module, this classes belonging to these packages are the public API, whatever are mentioned in this exported. So the app class loader, this app class loader will be able to see only the exposed classes. Other classes will not be visible. So for all other classes, they are not visible. So for example, here in HTTP module, they are using common slang 3.1, right? And let us see, is it being used somewhere else? Yeah, common slang 3.12 is used in sockets module. Let me actually use one more module I want to show you. For example, I will add Java module. Okay, which version? I will use 1.2.5, some other version of Java module. Now, if you see Java version 1.2.5, it is dependent on common slang 3. but a different version, 3.8.1 jar. Oh, so the HTTP module is dependent on 3.12. Java module is dependent on same common slang 3, but 3.8. Now what? Every module will have its own class load, right? If you see for this module also, there's a jar ending with -mule -plugin. So this is the main jar, and this main jar is having classes which internally use other jars. Okay, so let us see in this plugin jar, meta-nf, mule artifact, JSON. Here they have given exported packages. Only this package is exported. Only this package is exported. That means only the classes belonging to this package are visible outside. Okay, so do you think that the classes belonging to 3.8.1 jar of this common slang 3, they will be definitely used within this Java module, but are they visible to other modules? No, right? That is what I was saying. So actually for every module, there will be a separate class loader, right? And for every class loader, they have defined a public API. Where is the public API? Within the jar ending with -mule -plugin jar, under meta-nf, under mule artifact. In this mule artifact JSON file, they have defined their public API. Only the classes defined in these packages will be visible outside to other class loaders. So now can I say that even though Java module is using 3.8.1, of course, the Java module will use the classes belonging to this jar, but they're not visible to other modules. So other modules can comfortably use other versions of the same dependency, right? So that is the idea. So the concept is every application is treated as an artifact, and every module also is treated as an artifact. And in Mule, they have written a logic such that every artifact will be using its own class loader, right? So for runtime, system class loader will be used. And for system class loader, your application specific class loader will be a child. And for application class loader, DB and SOAP will be child. The modules will be child class loaders. So classes loaded by the children are not visible by default to other children, right? But only the parent can see the classes loaded by the child. But what classes? What is the public API? Only if in DB module, whatever is the public API defined, only those classes are visible and they can be used by the application. So that is how it works. Okay. Now I have a simple question. Let us think logically and answer this so that you'll get clear understanding. So assume that I have written a Java class. For example, I will write a new Java class. I'll use my package as in.lwww and class name is A. I wrote a class called as A. So now assume that I have a method here, public static return type is string, say hello, and just let us say it returns this method. Let us say it will take string name, and this will just return hello plus fine. Now I want to use Java module to invoke this class, invoke a method on this class. Yes, you know how to use it. So I will use Java module, and here is invoke static. Static. As you might be knowing, I can specify class name is yes, and once I specify class, I will be able to actually call the static method. It will show here say hello. Good. So now the question is, This Java module is this class invoke static is a component belonging to Java module. So let me draw this. This is the Mule runtime. And this is your app. Application uses its own class loader. And this will actually load the classes belonging to class path. Whatever are there in the class path of the application, they will be loaded by the app. So this application class loader, the class loader of the application will load whatever in my package in.lwww.a, it will load. And inside this, I have Java module. This Java module will use its own class loader, is it? Now, as I told you, classes loaded by the parent class loader will not be visible, right? How can the Java module see the classes loaded by the application class loader? So as I told you earlier, classes loaded by one class loader are not visible to other class loaders. But how is it made possible? How can the child class loader see the classes loaded by the application? That might be a question in your interview. Let me answer this. Very simple. Actually, if I just run this application at least once, if I build it, I want you to show. I'll stop it. I don't want. So now it is built. If I see here target meta-inf mule artifact, here is mule artifact JSON. If you see, my application also is an artifact, and in the class path meta-inf mule artifact, there is mule-artifact.json, and here by default, my in.lww package is exported. That means this became a public API, right? So whatever are exported will be visible to all other modules. So that's how my Java module is able to see the classes exported. Now, suppose if I don't want the classes in this package to be exported, what I can do is simple. In this mule-artifact.json. Actually, this project also has mule-artifact.json, right? So let me copy all this. Let me open this mule-artifact.json. It is very simple. It is having only min mule version. So what I could do is I can paste this entire thing. And I will just remove unnecessary things. Min mule version is required. Other things I will remove. Only thing is exported packages, I will make it as empty. If I write exported packages, whatever I write will be taken by the Mule. I will make this exported resources, let them be the exported packages I made as empty. And other things are not mandatory. I could remove this. Let me remove this. Fine. Let me run this application again now. The application is built. Now I'll stop. Now, if I go to target meta-inf mule artifact JSON, let us see here, exported packages, is it empty? Yes. So this package is not exported. So now actually at runtime, whenever the Java module tries to load this a.java class, whatever specified, it will throw an exception, class not found exception, right? So I hope you understood that for your application also there will be mule-artifact.json. Good. So now you understood about how in Mule class loading isolation issues are avoided, how Mule is taken care, because every module has its own class loader and every module defines its public API in which file mule-artifact.json. So every module is deciding what classes or what packages to be made visible to other modules. So as this is taken care, my DB module can use a different version of dependency, and my SOAP module can use different version of dependency. So that's about class loading. So in this video, you understood about this problem. In my next video, actually, I'm going to talk about how to have common shared flows between the applications. That is very important for interviews. I'll see you in next video and we'll discuss about it. Thank you.